Welcome back. In this video, we are going to take a look at combining like terms and solving multi-step equations. In the last video, we solved single-step equations, and all we had to do was add, subtract, or multiply, or divide in order to solve for the variable. Today, we're going to have multiple steps involved before we can solve for the variable. And one of the things we may have to do on one or both sides of the equation is to collect like terms. So we need to make sure we do a short review for collecting like terms. Remember that a term is like one chunk or a piece of an algebraic expression. For example, if I had 3x squared minus 4x plus 6, each one of these pieces or chunks would be a term. So we'll take out one of them. I'm going to take out the 3x squared and make sure that we remember the terminology that goes along with it. Remember that the letter involved in the term is our variable. And that is a letter that takes the place of a number. The little number up near the top is called an exponent. And the big number out on front, in front, that's multiplied by the variable is the coefficient. All of those are going to be very important when we collect like terms. In order to combine a term with another one, we could also say this as in order to combine. That does not say combine. They absolutely must have the same, well, what needs to be the same? They need to have the same variable or variables. They might both have x's, they might both have y's, or maybe they both have an x and a y, but the variables have to match. And if there are exponents, the exponents on the variables have to match. For example, if I wanted to add 3x squared plus 4x, my variables match. I have an x and an x, but I don't have a squared on the 4x. It's just a 4x. So these would not be like terms. I am not able to combine those because it's not 4x squared. If I've got a squared on one variable, like the x, I have to have a squared on the other x in order to put them together. The one thing that absolutely does not have to match, your terms do not have to have the same coefficient. It would be pretty boring if they did. Remember, the coefficient is the number out in front. So we can put two terms together If they have the same variable, if those same variables have matching exponents, but we do not have to have the same number out in front. So let's go take a look at some of these. On the first one, I need to make sure that my variables match. So I have an x and an x, so that's a really good thing. Then I need to make sure that I have matching exponents on my x's. I have a 3x squared, so I have an exponent of 2, and then I have a 4x squared, another exponent of 2. So my two requirements are met. Now, I'm going to add them up. If I think of these like cans of soup in my pantry, this would be 3 cans of chicken noodle soup plus 4 cans of chicken noodle soup gives me 7 cans of the same soup. The label on the can, and that's how I think of this part, doesn't change when you put them together. You still have the same thing, you just have them all in one place. You could also think about it as sorting your laundry. The type of laundry in each pile doesn't change just because you put more in the pile. So what we're really doing is we are combining the coefficients and we're keeping the variables the same. Let's take a look at this guy. I'm a big fan of color coding things. So here we go. I have a negative 2xy. And I need to see if I have anything else in my expression that matches the negative 2xy. I need a plain old x and a plain old y. I don't care about the coefficient. Well, if I go look at my middle term, I have a 5 and a y, but I'm missing the x. So I cannot combine 5y with negative 2xy. If I go look at my third term, I have a plain x and I have a plain y. That's all I needed to be able to combine my like terms. So I combine the coefficients. That means I do negative 2 minus 3, and I keep the variables and their exponents the same. Well, negative 2 minus 3 is negative 5. Now, since I don't have anybody to combine my plus 5y with, I'm going to bring it straight down and leave it alone. I'm not going to mess with it because I can't put him with anybody else. This one's a little bit longer, but I'm going to do like I did last time. I'm going to start with the first term and see if I have anybody I can combine with it. This time I have only a constant, no variables. Well, that means I can't use the second term because it had an x squared. If I look at the third term, I have another plain constant, no variables. So it can combine with the 4. If I go look at the last term, this positive 8x squared, it's not a plain constant. It has the x squared in it. So that has nothing in common with the first two, or with the two constants. So now I'm going to take a look at my other two terms. I have a positive 3x squared. So I can only combine that with other terms that have an x squared and only an x squared in them. When I look at my terms, the only one left to analyze is the last one. I have an x and it's squared, just like that 3x squared. So those two also count as like terms. I'm going to rewrite these so that my like terms are next to each other. So I would have 4 minus 6 plus 3x squared plus 8x squared. 4 minus 6 is negative 2. And then over here, I'm going to combine my coefficients. 8 plus 3 is 11. And I'm going to put the variable and its exponent on the back. So I end up with negative 2 plus 11x squared. This one is even a little more different than the other ones were. These all have variables, so we've got a little more work to do. My first term has an x and a y. Well, that second term only has a y, so it doesn't match. My third term has an x and a y, so I'm going to check my exponents. When I go check my exponents, there's a little invisible 1 as an exponent on the x. If I look over here, my x has an exponent of 2. So those definitely do not match. So my first term doesn't match anybody. A quick look at the second term tells me it's missing an x compared to the other two terms. And a quick comparison for the last term, it doesn't match the second one because it doesn't have the second one doesn't have an x. It doesn't match the first term because the exponents on the y's don't match and the exponents on the x's don't match. When that happens, all you do is leave it alone. You don't always get terms that you can collect. If you can't, you leave it just like it is and move on with your mathematical career.